As we see ourselves in a world with an unprecedented development in technology, we see our devices becoming increasingly advanced. Not only advanced, but smaller. With transistors scaled down to microns, it's important that the materials that make up our electronic devices are incredibly pure, with no defects or imperfections. The base materials for these devices are silicon semiconductors, which are the primary products of the company I interned for, SCH America. At SCH, an incredibly strenuous and large-scale process is used to create silicon wafers, where every single step of the process is regularly improved upon in order to help maintain a near 100% purity in their semiconductors. My work at SCH had me help improve the transfer process of the silicon ingots by designing and 3D modeling a component to minimize the metal-to-metal contact and potential contamination of the graphite plugs on the heater. To further explain, here you can see in figure 1.2, you can see the heater, which heats up the silicon in the beginning of the process, and sticking out at the bottom are two graphite plugs. After every single silicon crystal is formed, the heater must be taken out and placed onto a metal transfer cart to be taken to clean. Here in figure 1.3, you can see part of the transfer cart modeled in blue. This current transfer cart has 4 blocks, which are sort of used to keep the heater in place at the moment. But currently, or previously, the heater rested directly on the cart and supported its weight on the plugs, rather than supporting it by the heater itself, which put the graphite plugs at risk for either contamination or potential wear, as they are fragile components. So my job was to design and then 3D model a component to help prevent the contact between the cart and the heater plugs. Before I began brainstorming ideas, I had to follow a set amount of design constraints. That being, 1, the design must accommodate a removal tool, which is sort of a tool dropped in the center of the heater, and then it picks up the heater to move it from the machine to the cart. It also must be able to attach securely to the transfer cart. There has to be one design that must fit all 10 different sized transfer carts in the 2 different sized heaters that SCH uses. We also had to focus on a simpler design, as a simpler design will result in a cheaper cost, as it'll be less labor intensive and lower manufacturing costs in general. And most importantly, the plugs of the heaters, which is the main idea, the plugs of the heaters cannot come in contact with anything. So I began by sketching out some design ideas, which you can see in figure 1.1. These designs worked well in theory, but I found that in regards to the design constraints, they were all either too complex and would cost too much to manufacture, or weren't able to be accommodated to the different sized carts and heaters. So after some deliberation with my mentor, we decided to go with a simple 4-block design. In figures 1.3 and 1.4, you can see this design assembled and how it would fit onto the transfer cart assembly. This design has 2 large blocks and 2 small blocks, which match the shape of the transfer cart blocks. Each of the designs have 2 holes that can accommodate a screw in order to hard mount the design to the transfer cart. This design works in the sense that the sides of the heaters, which you can see here, are resting on the elevated blocks, so the graphite plugs are suspended in the air, which means it will have no contact with the bottom of the transfer cart. So overall, this is quite an effective design. It's pretty much about as simple as it gets, which will be incredibly important for manufacturing costs. And due to the simplicity of it, it's able to be mounted onto several different sized carts and heaters. However, there are some aspects that could have been improved. Currently, the design covers the whole top of the transfer cart blocks, which you can see in figure 1.3 again. But because of the round shape of the heater, it only rests on a certain part of the design, meaning that there's a lot of unnecessary and wasted space. So in the future, I'd hope to look into finding the best size blocks possible in order to be large enough to hold the heater and support it by itself, but not be too large where we're wasting money manufacturing unnecessary material. Thank you.